What if the most unbelievable sights in China aren't found in myths, but in modern infrastructure where engineering turns cliffs, voids, and moving water into systems that run every day? The shock begins on the Zhangjiajie Glass Bridge, a span about 430 meters long, hanging roughly 300 meters above the canyon, where every step feels like a direct test of structure, material, and trust. Then the impossible shifts from height to speed at the Bailong elevator, lifting you 326 meters in about 1 minute 32 seconds, turning a sheer rock face into a vertical transit line. And the scale moves up another level at the Three Gorges ship lift, where a ship elevator can raise vessels up to 3,000 tons through a height difference of about 113 meters, letting river traffic pass the dam as if the barrier didn't exist. So how do you design and build systems like this, when load, vibration, and safety leave no room for trial and error? And when the unimaginable becomes everyday infrastructure, where does the real limit of engineering actually sit? In the next moments, we're stepping inside the blueprint of impossible, breaking down the true scale, the technical logic, and the decisions that turn these projects from ideas into reality. Zhangjiajie Glass Bridge. A glass walkway stretches between two cliff walls with nothing beneath it but a sheer drop, forcing every design choice to survive wind, vibration, and zero margin. The Zhangjiajie Glass Bridge had to solve a blunt engineering problem first: how to span a deep gorge without planting support piers in the canyon or scarring the rock face. That constraint drives the structure towards suspension, sending the primary loads into cables and anchorage points where the cliffs can actually take and return the forces. It runs long enough, about 430 meters, that gusts and synchronized footfalls can act like inputs, not background noise. And it hangs high enough, roughly 300 meters over the floor, that any noticeable sway becomes a design problem, not a cosmetic detail. So the challenge shifts from can it stand to can it stay stable, which is why coverage of the project describes vibration control and wind simulation shaping stiffness, railing behavior, and how the deck is allowed to move. The walking surface looks impossible because it is transparent, but it is engineered to be forgiving, using laminated glass built in stacked layers that share load and keep damage from propagating. To translate that redundancy into something the public can understand, reports describe a staged demonstration where a heavy sledgehammer is driven into the surface repeatedly until the outermost sheet cracks and spiderwebs. Yet the layers beneath keep the deck locked together rather than opening into a hole. In other words, the test is designed to show a specific failure mode, surface breakage. While proving the deeper requirement, the load path remains continuous even when the top layer is compromised. Seen as an engineering work, the bridge is a controlled system that turns open air into a dependable corridor, designed to operate with disciplined limits instead of luck. Just beyond the canyon crossing, a glass cabin climbs a sheer sandstone wall, turning a cliff into a vertical corridor that has to run with the discipline of public infrastructure. At the Bailong elevator in Hunan, a route that can take about 2 hours on foot is compressed into roughly 1 minute 32 seconds over about 326 meters, which means the entire system is engineered around controlled motion rather than sightseeing. Instead of widening trails across steep slopes and spreading erosion outward, the project concentrates movement into one rigid line, using a stiff steel structure and anchored connections that transfer repeated loads into the rock where the cliff can actually resist them. At this height and this cycle rate, the hard problem becomes stability over time, managing vibration, wind-driven sway, and precise alignment. So the design relies on redundant braking and contingency power to keep the cabin within tight operating tolerances. Because a vertical route offers no shoulder and no easy access, the Megaproject challenge extends into operations as well, with monitoring, inspection access, and evacuation planning treated as part of the build rather than an afterthought. The achievement is practical and measurable. The cliff stops being a time penalty and becomes a scheduled link that moves large volumes through one controlled corridor instead of thousands of scattered steps. That efficiency has drawn criticism for diluting the traditional, earned ascent. But it also shows what this landscape demands: solutions that are bold enough to work daily without damaging more ground. And if one cliff can be reorganized into a reliable timetable, the harder question follows naturally. What does a mountain metropolis do when ridgelines and rivers leave almost no continuous road corridors, and mobility has to be engineered in 3 dimensions, as Chongqing Metro proves? A mountain metropolis has one central problem. Ridgelines and rivers leave almost no continuous road corridors, so mobility has to be engineered in 3 dimensions, as Chongqing Metro proves. With streets forced to wrap, climb, and double back, capacity cannot be added by widening lanes. It has to be redirected into tunnels, viaducts, and stacked junctions that keep flow predictable. So the network threads through rock where slopes would break surface geometry, then lifts over valleys and dense blocks where foundations are the only stable option left. That decision makes geology and proximity the main constraints, because alignments must manage groundwater, settlement risk, and vibration while running close to existing neighborhoods. The most famous example is the so-called train through an apartment, which is actually Lizzie Station integrated into a residential tower between floors 6 and 8 of a 19-story building. To make that coexistence viable, engineers use vibration isolation and noise reduction systems that decouple train loads from the living structure, keeping impacts from transmitting into homes. In the end, Chongqing Metro is not a spectacle. It is a city-scale logistics machine built to create continuous routes where the terrain keeps trying to break them apart. Three Gorges Shiplift. Once a mountain city proves that mobility can be engineered in 3 dimensions, through rock, over voids, and alongside neighborhoods, the same logic has to be applied to moving water. At Three Gorges Shiplift near Yichang, the central problem is simple but brutal. A dam creates a vertical barrier on a working river, and shipping cannot negotiate it by going around. Traditional locksteps can move vessels, but they do it through slow staging and long queues. So the design brief becomes a different question. How do you lift the traffic itself without breaking the river's schedule? The answer is a ship elevator, a water-filled chamber that receives a vessel, seals, and then rises as a single controlled platform instead of inching upward in stages. Operating specifications describe lifting vessels up to 3,000 tons through about 113 meters, which turns elevation difference into a single vertical transfer. To make that possible at scale, the chamber has to stay level under shifting loads. So synchronized hoists, cables, and control systems manage balance and motion with tight tolerances. Because the payload is not just mass, but moving water, gates, seals, and monitoring are engineered as a safety system, keeping the lift predictable even when river conditions fluctuate. In the end, the shiplift is the river version of a metro network. Not a spectacle, but a logistics machine that converts geography into throughput. Wuhan suspended monorail. Once a working river can be lifted like cargo in a vertical machine, the next question shifts back to cities. How do you move people without taking any more ground? Wuhan's suspended monorail answers with an unconventional premise. Instead of laying tracks on the surface or burying them deep, it suspends the train beneath a single overhead beam and lets the route live in open air. The engineering logic is clearance and footprint, keeping columns and right-of-way tighter than many elevated lines, so the system can thread through built-up districts without cutting the ground into wider barriers. That spatial restraint also supports an ecological corridor idea, where planners aim to reduce surface fragmentation across parks and waterfront greenbelts by keeping the main movement layer above. But building upward trades one set of problems for another, because a hanging train has to control sway, vibration, and precise spacing with disciplined automation and sensing. The benefit is not just circulation. It is a visible statement that the city is choosing a three-dimensional transit layer instead of one more fight for street space. In that sense, the monorail becomes both infrastructure and symbol, technology made legible in the skyline, while the ground below stays more continuous. And from here, the pattern is clear. Whether over canyons, cliffs, rivers, or city parks, the boldest projects solve movement by changing the layer where movement happens. Tianlong Mountain Road. If transit can escape the ground by hanging in the air, the next question is what you do when the route cannot escape the mountain itself and the grade becomes the enemy. Tianlong Mountain Road in Shaanxi is built around a simple design problem. The climb near the top becomes too steep to take in a single push without forcing dangerous slopes and unstable cuttings. So the solution is geometric rather than mechanical, using a three-level spiral that stretches distance in order to reduce gradient and keep traction, braking, and sight lines within workable limits. Instead of one brutal ascent, the alignment loops around itself, converting elevation gain into controlled curvature and repeatable turns that vehicles can handle reliably. That geometry also manages the mountain's constraints, because tighter corridors can reduce how much rock must be cut, where retaining is required, and how runoff is directed during heavy weather. What looks like a spectacle from above is really a calculation in motion. Turn radius, grade, and stability balance so the road behaves predictably near the summit. In engineering terms, the spiral is a compromise that trades distance for safety, making the final climb possible without forcing the mountain to give more than it can. And once the slope is solved by design, the story returns to systems again. Projects that reshape terrain not with one bold move, but with disciplined geometry. When a mountain road has to be redesigned just to make the final climb survivable, the same principle applies in a capital, except the bottleneck is not slope, it is volume. Beijing Daxing International Airport begins with a pressure test of a different kind, When air traffic pushes beyond what existing hubs can absorb, the choice becomes build a new anchor or accept cascading delay. Instead of scattering functions across multiple terminals and long transfers, the project consolidates operations into one mega terminal, so passengers, baggage, and gates remain tied to a single, continuous circulation spine. That one-piece strategy is costly, but it solves a daily logistics problem at the source. Shorter internal distances for critical systems, fewer connection points to fail, and expansion planned as an organized sequence rather than a patchwork. The terminal is on the order of 700,000 square meters and entered service in 2019, a scale that forces structure, utilities, and security flow to be designed as one integrated machine. With that much roof and that many routes to coordinate, the engineering achievement is less about a single iconic form and more about keeping throughput stable. Rail links, road access, check-in, screening, and boarding synchronized under one plan. And once the terminal itself becomes the control system, the airport stops being a building you pass through and becomes infrastructure that prevents the capital's mobility from collapsing under its own demand. A night sky that normally swallows detail is turned into a controllable medium, where thousands of independent aircraft have to behave like a single machine. In Liuyang, Guinness World Records certified 15,947 multi-rotor drones airborne simultaneously from a single computer outdoors on October 17, 2025, setting a benchmark that is more about coordination than imagery. At that scale, the engineering problem is failure propagation. One timing slip, one position drift, or one radio gap can ripple outward unless the system is built to contain it. Reporting on the event points to high-accuracy positioning and mesh-style networking to hold spacing and timing under real conditions, turning choreography into a control and redundancy discipline. The same date produced a second certified mark, 7,496 fireworks launched by multi-rotors in an aerial display, linking Liuyang's legacy craft to a software-driven flight grid. That combination is the meaning of the project. Light becomes programmable and repeatable, while pyrotechnics become an integrated payload rather than the entire show. In mega-project terms, the record is not a bigger show, but proof that large-scale swarms can be scheduled, constrained, and verified. An operational capability, not a one-off stunt. Right beside the spectacle of drone shows, China has been turning the same coordination logic into delivery, treating the sky as a logistics layer, not a stage. With Meituan service, customers place orders through the standard Meituan and Meituan takeaway apps, then collect items from nearby drone drop-off lockers rather than expecting door-to-door flight. That handoff choice enables the real design. Hubs launch along predetermined flight corridors to fixed pickup kiosks and drop zones, so routing becomes repeatable and auditable in dense urban airspace. By removing the last few unpredictable meters, the network can focus on what scales: dispatch timing, separation, monitoring, and strict geofencing, rather than improvising around every building and crowd. Official city reporting in Shanghai described the footprint by mid-2024 as 31 air delivery routes across key cities and over 300,000 fulfilled orders, which is the difference between a demo and a network. Operationally, each node is engineered like a miniature airport: loading, charging, launch sequencing, and return, where the ambition is a turnaround measured in seconds, ideally under 60 seconds, so throughput is set by flight cycles, not ground delay. This expansion is being pulled forward by regulation and planning around the low-altitude economy, with updated aviation rules and corridor concepts designed to make routine unmanned operations governable at scale. So the story is not a drone carrying food, but a deliberate systems build, hub to corridor to kiosk, where airspace is treated as infrastructure that can run every day. Chongqing Grand Theater. Once the narrative moves past the dense technical builds, the focus shifts from precision mechanics to broader meaning: how large civic projects reshape a city's identity over time. Chongqing Grand Theater stands at a river junction where land is scarce and visibility is everything. So the project is conceived less as a building and more as a marker on the urban map. Rather than expanding outward, its mass is consolidated into a single form, an approach that simplifies circulation and makes the complex legible at city scale. Public reporting consistently frames the theater as part of a wider cultural push, using architecture to anchor the waterfront and signal Chongqing's role as a regional center, not just a transport hub. The engineering challenge here is not extreme height or speed, but coordination, structure, acoustics, public access, and riverfront conditions brought under one coherent system. By concentrating performance halls and public spaces into one envelope, the project reduces operational friction and keeps daily use predictable despite its sculptural appearance. Over time, venues like this work less as destinations and more as stabilizers, giving the city a shared reference point amid constant growth and change. In that sense, the theater follows the same logic seen throughout this video. Compress complexity, control variables, and let large systems quietly support everyday urban life. Shanghai Tower. As the focus widens from individual systems to city-scale signals, the question becomes how a skyline itself absorbs growth without breaking the ground below. Shanghai Tower rises as a response to that pressure, using height rather than sprawl to concentrate offices, public space, and infrastructure into one vertical core. Instead of treating extreme height as spectacle, the project frames it as an efficiency problem, where structure, wind behavior, and energy use have to be balanced so the building performs predictably every day. Its twisting form is often described symbolically, but at a system level, it reflects an attempt to manage environmental forces and reduce loads that would otherwise compound at this scale. Inside, stacked zones replace the idea of a single-purpose tower, allowing different functions to coexist while sharing services, circulation, and safety systems. Official descriptions consistently emphasize sustainability and long-term operation, positioning the tower as part of a broader strategy to handle density rather than an isolated icon. Over time, buildings like this shift the logic of development upward, relieving pressure on streets and utilities by absorbing activity vertically. Seen in context, Shanghai Tower is less about reaching higher than its neighbors, and more about proving that extreme scale can still be organized, regulated, and lived with as part of an everyday city. Qingdao Bay Bridge. As coastal cities expand faster than their shorelines can absorb, the underlying problem becomes continuity. How to keep daily movement intact when water repeatedly interrupts the urban grid. Qingdao Bay Bridge emerges from that pressure as a city-scale connector, extending road infrastructure across open water instead of forcing traffic into long, inefficient detours around the bay. Rather than treating the sea as a hard boundary, the project reframes it as a passable corridor, allowing separated districts and development zones to function as a single metropolitan system. At this magnitude, the challenge is less about building a long bridge and more about maintaining reliability in a marine environment where wind, salt, and tides place constant stress on structure and operation. Planning narratives around the bridge consistently emphasize flow and integration, positioning it as a backbone that links ports, industrial areas, and residential growth without overloading coastal streets. By redistributing traffic away from the shoreline, the bridge acts as a pressure release, preventing congestion from concentrating in areas that were never designed to carry regional volumes. Over time, infrastructure of this scale changes habits quietly, shrinking perceived distances and reshaping how people and goods circulate around the bay. Within the broader pattern of China's megaprojects, Qingdao Bay Bridge illustrates how engineering can dissolve natural separations and turn geography into a continuous, dependable framework for urban growth. Zifeng Tower. As cities with deep historical layers continue to densify, the underlying challenge is how to concentrate modern commercial activity without overwhelming already constrained ground-level networks. Zifeng Tower responds to that pressure by stacking offices, hospitality, and public functions into a single vertical structure, reducing the need for further outward expansion in the urban core. Rather than acting as an isolated landmark, the tower is conceived as an organizational spine, drawing circulation, services, and utilities into a controlled vertical system that can be managed day after day. At this height and intensity of use, the real difficulty shifts to operation. Elevators, safety systems, and internal flows have to remain stable under constant demand without spilling pressure onto surrounding streets. In planning narratives, the building is often framed as a signal of economic transition, using vertical consolidation to accommodate growth while limiting additional land consumption. Seen alongside other large-scale projects, Zifeng Tower reflects a broader strategy where cities absorb change upward, keeping expansion disciplined even as scale increases. As dense cities search for ways to add culture without surrendering more land, the challenge becomes how to stack public life vertically while keeping it accessible and legible. 1,000 Trees approaches that problem by treating a building as an artificial hillside, where terraces step upward and greenery becomes part of the structure rather than decoration. Instead of separating architecture and landscape, the project merges them, allowing commercial, cultural, and public functions to occupy different levels of the same mass. This approach reframes density as an opportunity, using vertical layering to absorb activity that would otherwise spread horizontally and strain surrounding neighborhoods. From an urban perspective, the design acts as a buffer, softening the edge between busy roads, former industrial land, and emerging cultural districts. The engineering task here is coordination rather than extremes, aligning structure, planting systems, circulation, and maintenance so the complex can operate reliably over time. Planning discussions often highlight its role in reusing waterfront and industrial zones, signaling a shift toward hybrid developments that blend civic space with private use. Within the larger pattern of megaprojects, 1,000 Trees illustrates how cities can compress complexity into a single form and still leave room for public life to grow upward. As cities look for new ways to build without consuming scarce surface land, the challenge shifts toward using spaces that were once considered unusable. Intercontinental Shanghai Wonderland responds to that pressure by placing a full-scale hotel inside a former quarry, turning a deep industrial void into usable urban infrastructure. Rather than rising above the skyline, the project develops downward, using the quarry walls as a natural enclosure that defines structure, views, and environmental conditions. From an engineering perspective, the difficulty is coordination, stabilizing rock faces, managing water, and integrating building systems into a site never meant to host permanent occupation. Planning narratives often frame the hotel as a proof of concept, showing how extreme sites can be repurposed instead of abandoned, reducing the need for further outward expansion. In the broader sequence of megaprojects, the Wonderland Hotel represents a shift in ambition, where design is used not to conquer new land, but to reclaim and reorganize what was already broken. As coastal regions compete for large-scale leisure destinations, the underlying challenge is how to concentrate massive visitor flows without overwhelming surrounding cities. Chimelong Ocean Kingdom is conceived as a self-contained system designed to absorb crowds, logistics, and operations within one managed footprint rather than spilling pressure outward. Instead of functioning as a single attraction, the park is organized as a network of themed zones, allowing circulation and capacity to be distributed and regulated throughout the site. At this scale, the engineering focus is coordination, ride systems, water management, animal care, energy use, and crowd control aligned so daily operation remains predictable. Planning materials often emphasize resilience because coastal weather, seasonal peaks, and continuous use require infrastructure that can adapt without shutting down the whole complex. By integrating hotels, transport access, and support facilities on site, the project reduces friction between tourism and the surrounding urban fabric. Over time, developments like this act as regional magnets, reshaping travel patterns and concentrating economic activity into controlled environments. Within the landscape of megaprojects, Chimelong Ocean Kingdom demonstrates how entertainment itself becomes infrastructure, engineered to manage scale rather than simply attract attention. Gate to the east. As cities modernize along historic waterways, a recurring challenge is how to signal economic ambition without erasing local identity. Gate to the East was conceived as a symbolic threshold, using a monumental form to mark Suzhou's transition from classical gardens to a contemporary business district. Rather than spreading development across multiple towers, the project concentrates offices and services into a single, highly visible structure that acts as an urban marker. From a planning perspective, the emphasis is legibility, creating a clear focal point that organizes surrounding growth and infrastructure around it. Public discussion often frames the building as a statement piece, where architecture is used to communicate openness and scale in a rapidly changing city. Within the broader pattern of megaprojects, Gate to the East reflects how symbolism and infrastructure can merge, turning a skyline gesture into a stabilizing reference for long-term urban expansion. As dense capitals search for new civic anchors, the challenge becomes how to introduce large public space without adding friction to already overloaded districts. The place addresses that need by organizing shopping, circulation, and gathering space around a central pedestrian corridor, rather than dispersing activity outward. Its defining feature is not height or mass, but scale overhead, where a vast digital canopy reshapes how people move, pause, and orient themselves in the city. From an urban systems perspective, the project functions as a pressure absorber, concentrating crowds and events within a controlled interior environment instead of spilling into surrounding streets. Within the sequence of large-scale developments, the place illustrates how contemporary infrastructure can prioritize managed public experience as carefully as transport or commerce. As cities prepare for events that draw global attention, the real challenge is not spectacle, but control. How to absorb sudden intensity without destabilizing the surrounding city. Hangzhou Olympic Sports Center was planned as a consolidated sports district, grouping major venues and open space into one coordinated system, rather than dispersing them across the urban fabric. This concentration allows transport access, security screening, and crowd circulation to be designed as a single logic, reducing friction during peak surges. Instead of treating large events as rare exceptions, the complex is engineered to handle repetition, with layouts that can expand for international competitions and contract for everyday use. From an infrastructure standpoint, the emphasis is predictability. Utilities, transit links, and public routes align so capacity can be scaled without improvisation. Planning narratives often highlight its role beyond sports, positioning the site as a long-term civic platform rather than a one-time event venue. In the sequence of megaprojects, Hangzhou Olympic Sports Center shows how contemporary stadium architecture functions as urban infrastructure, built to manage extremes and then quietly return the city to normal. As coastal regions push to expand energy supply without crowding land, the challenge becomes how to move heavy infrastructure offshore and keep it operating reliably. Jiangsu Rudong offshore wind farm represents that shift, placing large-scale generation into shallow coastal waters where space and wind resources are more consistent. Rather than a single installation, the project functions as a distributed system, with turbines, foundations, and subsea connections organized to behave like one power-producing network. At this scale, engineering emphasis moves from construction alone to long-term operation, because marine conditions demand structures that can endure corrosion, waves, and continuous loading. Planning discussions often frame Rudong as part of a broader coastal energy strategy, using offshore wind to reduce pressure on inland grids and fossil fuel capacity. Within the wider story of megaprojects, the wind farm shows how infrastructure can migrate seaward, turning open water into a stable extension of the national energy system. As cities search for new ways to express technological ambition without defaulting to height, the challenge becomes how to signal innovation through form and function together. Phoenix Center responds to that question with a continuous, looped structure, using geometry to create identity rather than relying on vertical dominance. Instead of separating buildings into isolated towers, the project links offices into a single, flowing volume, allowing circulation and shared space to be organized as one system. From an engineering standpoint, the emphasis is coordination, structure, facade, and internal movement aligned so the complex operates smoothly despite its unconventional shape. Public descriptions often frame the center as a symbol of China's media and technology sector, using architecture to communicate openness and connectivity in a dense district. Within the sequence of megaprojects, Phoenix Center illustrates how contemporary urban landmarks can function as infrastructure for collaboration, not just as objects on the skyline. As design-driven cities reach a more mature phase, the central challenge becomes how architecture can communicate brand ambition while still functioning efficiently as everyday infrastructure. Maris Frog Building was conceived as a corporate anchor that brings offices, showrooms, and creative workspaces together, reducing fragmentation across multiple sites in a fast-moving city. Rather than adopting a conventional box or tower, the building uses a sculptural, biomorphic form to project identity outward, turning the structure itself into a visual extension of the fashion brand it houses. That expressive geometry introduces complexity, which means structure, circulation, and building services have to be carefully coordinated so visual impact does not compromise daily operation. From an urban perspective, the project reflects Shenzhen's broader shift from pure manufacturing toward design, branding, and creative industries that rely on image as much as output. Internally, stacking key functions into a single volume shortens workflows and keeps collaboration concentrated, an organizational advantage in a highly competitive creative environment. The real achievement lies in balance, maintaining a strong architectural statement while ensuring the building behaves predictably under constant use. Within the larger sequence of contemporary Chinese projects, the Maris Frog building illustrates how corporate architecture can evolve into strategic infrastructure, supporting identity, efficiency, and long-term adaptability at the same time. As regional capitals move beyond basic growth targets, a deeper question emerges about how cultural infrastructure can be planned with the same seriousness as transport or energy systems. Jiangsu Grand Theater was developed as a comprehensive cultural anchor, bringing multiple large-scale performance venues together into a single, deliberately organized complex, rather than scattering them across the city. Instead of relying on vertical monumentality, the project spreads horizontally along the waterfront, using controlled massing and orientation to establish presence while keeping access, loading, and circulation manageable. This configuration allows audience flows, backstage operations, and public gathering spaces to be planned as one continuous system, reducing friction when several halls operate at the same time. From an engineering standpoint, the real challenge is integration, aligning structure, acoustics, stage technology, and environmental systems so the complex performs reliably across different event types. Urban planning narratives often position the theater as part of a wider civic strategy, where cultural institutions are used to stabilize new districts and give long-term identity to large developments. By consolidating regional performance capacity into one site, the project limits redundancy and creates efficiencies in management, maintenance, and daily operation. Within the broader sequence of megaprojects, Jiangsu Grand Theater represents a mature approach to scale, where ambition is measured not by visual drama, but by how well complexity is organized over time. As cities along major lakes and waterways look for recognizable anchors, the challenge becomes how hospitality architecture can act as both destination and infrastructure. Sheraton Huzhou Hot Spring Resort was conceived as a landmark hotel, using an unconventional circular form to establish a strong visual identity without relying on extreme height. Rather than spreading across the shoreline, the building concentrates rooms, services, and public amenities into a compact footprint, preserving open waterfront while keeping operations centralized. From a systems perspective, the complexity lies in coordination, because structure, facade, guest circulation, and waterfront conditions all have to function smoothly within a highly expressive form. Planning narratives often frame the hotel as part of a broader tourism strategy, using architecture to signal quality and permanence while supporting steady, long-term use. Within the sequence of large-scale projects, Sheraton Huzhou shows how hospitality can be engineered as civic presence, balancing iconic design with the discipline required for daily operations.